Hello everybody, welcome back. Today we shall build a simple Chrome Dino type platformer game which will have two levels. So that's quite a mouthful. Uh, this is a fairly interesting game with lots and lots of things. This is, as you know, a part of our Scratch programming course. This would be class number 10 of this course, right? So before getting started, let us see what the game that we are building will look like, right? So it's a game for which we have taken inspiration from the Google Chrome Dino. So you might have noticed that if you have problems getting internet connectivity, then Google lets you play this game called the Chrome Dino, and this game we are building today is similar. So here we have a cat taking a walk in the park. It's kind of like a clouds and road mark, right? I have to jump the cat over the trees, right? And our goal is to make sure the cat doesn't touch the trees. If it does, like it did just now, there's a cat lives keep going down, right? Now, so the game continues. If I reach, so if I have still lives left and it becomes 30 seconds, then we go into level 2, right? So level 2, everything becomes faster, but we get this booster butterflies, right, which can give us an extra life, right? So we are going to build, and the game continues like this, right? So we are going to build something like this today, right? Which looks fairly complicated with lots and lots of moving elements, right? However, as we'll notice, there are parts of this which are very similar to the other games that we have built, right? So let's get started, right? So the first thing that we will do is to add a right kind of backdrop for this, right? So what I'll do is that I will say go choose a backdrop, right? And the backdrop I'm using is a simple blue sky backdrop, which is basically blue sky 2 in Scratch, right? So once I do this, I have got the Scratch, blue sky backdrop. Now I am going to modify this backdrop a little bit to give me this like a road here, right? You notice this like a black line. So this modification is very simple. I'll go to the backdrop, right? I select the backdrop and I'll I will draw a line, right? So I select a line here, right? Maybe outline 4 is fine, and I just draw a line somewhere, say somewhere in the this part, right? So somewhere basically towards the lower part of this, this backdrop. So that kind of creates a feeling that this is a line, right? And you notice the moment you draw it here, it immediately appears in the playground as well, right? In the stage. Yeah. Now this is where my cat is going to move. Okay. So the next thing I'm going to do is that I'm going to place my cat on top of this road because cat is really walking on this road. So I'm going to place my cat on this road, right? So and how do I do that? The simplest way would be to first make sure that you place the cat here because the cat should be somewhere here and note down what are the y coordinates. All right, so what are the y coordinates? Okay, now my this cat is looking rather big as well, so I'll first make it, let's say 50% of its size. Again goes up, I'll go and place it here and look at the y coordinates, right? So in this case y looks like minus 77, right? That's simply a function of where my black line was, right? So maybe I can try, let's say if minus 75 looks any better. So yeah, minus 75 looks just nice for this. So I'm going to use some code to place my, uh, you know, uh, to basically make sure that my sprite ends up on this position for y, right? Now, depending on where your black line is, for you, this value might be a little bit different, but that really doesn't matter, right? So shouldn't be bothered about that too much. It's all right, right? So I'm using minus 75 here. That's because at 50% size, it makes my cat sitting, sort of standing nicely on uh, top of this road. So now that my cat is standing on this road, right, I can now give it a code to make sure it walks, right? However, before doing so, I want you to notice one thing very, very important in this game. Okay, so here my cat is say somewhere at this point, when I click the flag, right, it looks like the cat is walking and looks like it's moving forward, right? But really speaking, the cat has not moved even a centimeter with respect to this thing here, right? If you notice, this is a fixed point, this time thing. Cat is always underneath this, right? So really speaking, the movement that we are creating is an illusion, right? So given this, since the cat is really going to be at one particular point, we can just, we can maybe say put it at minus 155, right? So we can do this once from here, or if you want, you can use go to this particular position, and that's it, right? So cat is really not moving in this in the x direction, right? So that's an amazing part of this game which has to be realized. Yeah, now we shall give the cat the code that it looks like it's moving, and we do that using cat's costumes, right? So notice cat has two costumes, one is this and another one is this, right? So when I flip between these two costumes, I get a feeling that the cat is walking, right? So we shall use this in our code now to create an illusion that the cat is walking, right? So notice I'm writing for the cat. So I say, look, in the events when flag clicked, right? So I'll make sure it goes there. So I'll say go to, let's say minus 155, minus 75, right? Then I'll say in the looks, I shall go and say show, right? And now this is back to one of the earlier classes, right? Forever, I just have to do in the looks, I can go and say next costume, right? And just to make it look a little bit more, sort of stable, I'll add a small weight here, right? So if I did this, let's say weight of 0.1 seconds, right? So what happens is the moment I do this, notice my cat looks like it is now walking, right? It's although please take into account, take note that it's really stationary on this point, right? And the illusion of walking will come later on when we have things moving towards the cat, right? We'll build that in just a moment, right? Now, having given the code for the cat to walk, let us now give it the code to do the next important thing, which is, let's see here, which is the act of, so when I click flag, when I click the space bar, the cat jumps, right? So we will now give the cat the code to jump. Okay. Now it turns out that if you search in the internet, if you look at many Scratch projects, people build extremely elaborate jumps by looking at laws of science, gravity, and so on and so forth. But for the purpose of this game, we are coming up with a very much simplified version of jump, which suffices our purposes, right? So what really jump is essentially the cat should go up, right? It should stay there for just a brief moment and then should come down, right? So that's basically like like a simple jump, and we are going to build that now. So let's do that slowly. I'll say, in the events when flag clicked, right? So notice this was just to make the illusion of movement. Now I'm writing code to make the cat jump. Yeah. So I'll say, I want the cat to jump when I click the space bar, right? So I'll say if, for example, if key space bar pressed, then I shall say, and pay attention to this. It's very simple, but it's just a way to make the cat like it's jumping, right? So I'll say repeat 5 times, right? Change y by 10, right? So what will this do? This will basically change the cat's y position by 10 steps, which means it will push this up. So I'll say motion change y by 10, right? So now this particular repeat 5 will make sure that cat changes y position by 50 steps in steps of 10. And to demarcate each of these, I will add a little bit of weight here, right? So what this does is it will cause the cat to slowly jump up 10 steps at a time to reach a certain height, right? Now remember, jumping is like you go up, you pause there briefly just for a very brief moment, and then you come down, right? So to do so, I will add a small weight here, right? So let's say weight of 0.1 seconds. And now I will take this code and duplicate without the second weight, and I'll just add this here. But this time I want the cat to come back 10 steps, right? So I'll put it wait of minus, so repeat 5 times, change y by -10, and wait 0.01 seconds again, right? So for every step. So this is a simple jump that I've created. Like I said, you are most welcome to do other forms of jump, right? People spend a lot of time, lot of energy defining what a jump is, but this is a simple one which will work. Right now, you may wonder why I am doing all of this repeat and this and that. That's because I want to create the jump which looks somewhat realistic, right? You can try it yourself. If I did, let's say, change y by 50, because that's what I'm doing here effectively, 5 times 10 is 50. If I change y by 50, change y by -50, it doesn't quite look as realistic, right? So I did some experimentation and I came to this. Yeah, like I said, you are most welcome to change, right? At this point of time, right, I want you to just pause this video and think in your mind, what is the mistake that we still have in this code, right? This code will actually not work because I've left a very important block, right? So please pause the video, think for yourself what could be going wrong. All right, so the block that I'm missing here is the block called forever, right? So if I have a forever block, then it will make sure that my cat will always jump when the space key is pressed. Otherwise, it will happen only when the flag is clicked, right? So forever is the block that I need. Now with this done, right, you notice my cat has got, when I click the flag, it kind of gives me a jump, right? And it looks reasonably realistic. It's not, the perfect jump, but it's pretty good enough for our case, right? So like I said, if you have a different idea of how to implement a jump, that's also fine. No problem about that. Yeah. Uh, but you must make sure that the cat comes back to the same Y position, right? So if you are moving up by 50 steps, you must make sure that you move down also by 50 steps. Otherwise, the cat will be either going too high or too low. All right. Now, notice, let's analyze this jump a little bit carefully. So notice here, I'm moving by I'm moving 5 steps in steps of, moving 5 times in steps of 10, right? So really I'm moving 5 steps, right? 50 steps, right? Let's say I want to be able to control my cat so that it can go higher or lower, right? It can jump higher or jump lower. I really have two options here. One is that I can change this 5 to, let's say, something like, let's say, 8. Let's say if I made it 8, then really my cat is going to jump higher because it's, you know, so notice the cat is jumping higher now whenever I'm clicking the space bar. That's because instead of repeating this 5 times, it's repeating 8 times, and then it's also repeating 8 times downwards. Make sure these two are exactly equal. Otherwise, there'll be a problem, right? The other thing I could also have done is to change my y by a larger step, right? But the effect is the same. So I'm going to create a variable that controls how high my cat jumps, right? So to do so, I'll create a variable called, let's just call it cat jump repeat steps, right? So this is just a name I give, which is very explicit in what it's doing, what the purpose is, and so on, right? So I say when flag clicked, right? When flag clicked, uh, set cat jump repeat steps to, let's say, 10, or maybe 10 is too high. So let's say I make it 7, right? 7 is just nice. And here I will say repeat, instead of fixed number 8, I'll say repeat. Yeah. So, right. So what this will do is that this has given me the control on how high my cat jumps. And as you will notice later on, you will need this control in your game to fine tune and make sure that everything is working fine, right? Because how high the cat jumps is something that will determine how easy or how hard your game is to play, right? So it's good to have that little bit of control, right? So let's see this now, right? So we will have, whenever I click the space bar, the cat jumps and it comes back, right? Now notice cat is really not moving from its X position, is just at that position changing costume, right? So we've got this code already. The only thing I'll do, little bit of a beautification here, I will go to the sounds block. I've already got a meow sound here, so I shall go to sounds here and start sound meow whenever the cat is asked to jump, right? Now notice I'm using start sound here because this is not a background music. This is just an event music which happens when I click the the space bar, right? So if I do this now, notice my cat is having a very nice jump, right? Yeah. Okay. So let's move forward now. Let's go back to our this game, right? So cat's job is kind of done, right? But now we have in this game we have, of course, we have some stuff coming towards cat, right? So we notice that we have got trees, clouds, and the road marks moving from right to left, right? So we are going to build this now, starting with the tree. Now you might wonder, why do I start with the tree? Why not with the cloud, right? The reason is that I am picking up the sprite which is most important to my game. All right. Now my game will not be complete without the trees, because the essence of the game is the cat taking a walk in the park and jumping over the trees, right? However, my game can still feel complete without the clouds and without the road marks. Those are just for beautification, right? So we shall first go and implement the code for the tree, and then we'll see what to do for the cloud and road mark. Yeah. Now we shall now bring in a tree sprite, right? So tree sprite is a sprite in Scratch, right? So I'll just search for tree, right? And I'll use this trees sprite, right? Now notice it looks rather big, so I will make it small because I want the cat to be jumping over it. So say 20% is just nice. Now having set it to 20%, right, I will make sure that my tree is standing on the road, right? So I'll just try to use my mouse and place it somewhere here, let's say, right? Notice that this Y position here, right, may be different for the tree and the cat, and that's just because their sizes, their geometry is a little bit different, right? But the whole point is that tree, just like the cat, should be nicely stationed on the road, right? So I do not want the tree to be here, there, somewhere like that, right? So I shall just make sure the tree is standing there. Okay. And now I'm going to create code to make sure that the tree comes from right to left, right? Now notice one thing, that whenever we have a situation where we have a sprite, many copies of it doing something, more likely than not, right, I would have used cloning, right? So cloning, remember, is the method by which we can make copies of a sprite and make each sprite do something. Yeah. So that is the most efficient method of building something like this. So clearly we shall use cloning for our purpose, right? So in fact, I want you to notice that the cloud, the tree moving from right to left is really not much different from the bullet of retro in the last game moving from right to left, right? So we shall use a very similar piece of code. However, there's a little bit more elements to this which we shall build, right? So as we always do in, regularly do in the cloning things, now I'm writing for the tree. So first thing I do is to say that when flag clicked, please hide, right? So I do not want the tree to show up here. So I just say, you know, when flag clicked, hide. Okay. Now I'm going to say, let's build this slowly. Okay. So let's say I write a code that when flag clicked, say I say, just like what we did for the retro bullet, right? I'll say, forever. Let's say I say, wait 1 second and create go to control and say, create a clone of myself, right? So notice here, in the case of retro bullet, retro was creating a clone for the retro bullet. Here I am telling the tree to make a clone of itself, right? So tree is saying make a clone of myself every 1 second, right? And this is incomplete because cloning requires 3 parts. So I must have a statement when I start as a clone, right? So I do that. I say, okay, look, tree, when I start as a clone, what do I want to do, right? First thing first, I want the tree to show, right? So I'll say show. Okay. So when I start as a clone, show, right? Now I will say, please go to something like this, right? Somewhere here, right? So what I can do is to say that go to, right? Um, this going motion, okay, motion, go to, right? I basically want it to go somewhere towards the right, right? Uh, and also want to make sure that the clone is also standing on the road, right? So I know that y equals to minus 84 works quite fine for that. So I'm not going to touch minus 84. However, I'll make this something like say 220, right? And before you implement this, just click this once to see where it ends up. So it's pretty much in the corner. I can push it out a little bit further, say 225, right? And this is fine. Right now I do want to make sure that the clone is not touching the edge, right? So there's a small gap here, which is fine, right? And we will see that in just a moment, right? So now if I write this code, basically it will start a clone, it will send the clone to that point. Now just like the retro bullet, I want the clone to move from right to left. Yeah, so I want the clone to move from right to left. And how do I do that? It's exactly same as retro bullet. So I'll say, go to control forever. I can use move statement, or all I can also use another block which is interesting to say change x by, let's say I say here, maybe I say, let's say I say minus 5, let's say. Okay, so I say change x by minus 5. uh, what this will do is that whenever a clone is created, it will go to the corner here. First thing it will show, it will go to the corner here, and it will start coming from right to left towards the cat. Okay, remember, however, cloning is not complete until I have the third block of cloning, which is what do I do to delete this clone, right? That's equally important. So I shall say if touching edge, delete this clone, right? Just like the retro bullet, because once the clone reaches this edge, I want it to get deleted, right? So what I'll do is to say in the control blocks, I'll say if, right? Let's say sensing, I'll go and say if touching edge, then simple, just go and delete this clone, right? So this also brings me to an important point, that remember when I was placing this clone in the beginning, right, at say 225, I was telling you not to make it too close to the edge, so close that the clone is touching the edge, right? Because when that happens, it's likely that your clone will get deleted as soon as it's created, right? You do not want that. You want the clone to travel all the way to the right, from the right to the left, and at that point get deleted, right? So for that purpose, I'm saying that, do not make it touch the edge, just make sure it's a little bit off the edge, because we have a condition that if touching edge, delete this clone, right? So now with this, right, if I see this, what's going to happen is my cloning part is actually kind of complete. We'll add more elements to it as we go on, but let's see what this does, right? So this piece of code will make sure that every 1 second one clone of the tree is created, and when that clone is created, when I start as a clone, it goes to this corner here, 225 minus 184, and it changes x by minus 5. So it means x will become 220, then 200, let's say 200 20, 215, 210, and so on and so forth. So which means x will start moving backwards, just like the retro bullet. Okay, so let's just see this in action. What happens here is that every 1 second, I am getting a clone of the tree walking towards myself. That clone reaches the edge and it deletes itself, right? Because of this particular command. So everything looks nice and on the right track. Now let's say instead of one clone, I wanted to create two clones every time 1 second gets over, right? So every 1 second, if I wanted to create two clones, what could I do? The simplest thing would be, I don't have to touch anything here because each clone must do the same thing. But instead of creating one clone here, I can put this in a repeat loop, and I say repeat, right? Repeat, say, let's say 2 times, right? Create a clone of myself and just give a small weight, right? Let's say I give it a weight of say, maybe let's say 0.05 seconds or something like that, right? So very small number, let's say 0.05 seconds, right? So now what will happen is, you notice when I click the the flag, every time I'll get two trees coming towards the cat, right? Notice that there are two trees coming because I'm saying repeat 2 times two trees, right? Now what if I want sometimes one tree, sometimes two trees, right? So the game is a little bit more interesting, right? So I want sometimes one tree, sometimes two trees. So it's very simple. I can give a dice to my cat, right? And throw a dice. If you get one, then create one clone. If you get two, create two clones, right? And what is a dice? Dice is basically a random number generator, right? So here I'll say, look, cat, pick a random number between say 1 to 2, right? You can say pick a random number between 1 to 2, create that many clones, and wait a little bit. So if I'm creating one clone, for example, it'll just create one clone. If I get two, then it'll repeat this twice, right? So this repeat will ensure that I'll sometimes get one clone, sometimes get two clones, right? So I'll get, let's say, two this time. I again got two, then I got one, right? So now it's become random. Sometimes I get one clone, sometimes I get two clones, right? Some of you might be wondering, why don't I do more than two? You can, but remember what I said, that the larger the number of clones that you are generating, the higher the cat must jump, right? So you must have the ability to make the cat jump over all of that. So it turns out that, which is why I said we have kept the cat height as a variable that you can fine tune. You will have to fine tune the cat height and the number of clones together, right? So that the game becomes reasonably okay to play. Now let's say, now, notice that this game is very predictable. I know that every 1 second there will be some trees coming towards me, right? Let's say I want to avoid that, right? So how can I do that? Say instead of 1 second here, let's say again I put, instead of 1 second here, that is, I put a random number of weight for the cat, right? So for the tree, sorry. So instead of one, if I, let's say, put weight, let's say for example, I say 3 to 5 seconds, right? So now what will happen is, sometimes it might wait for 3 seconds, sometimes it might wait for 4 seconds, sometimes for 5 seconds, and so on. And each time the clone is created, sometimes there's only one clone, sometimes there are two clones, right? So with this, what will happen is, you will see that the waiting time will also become variable. So the game is quite interesting. You can't predict anymore. So I got two trees this time. Now for a long time there's no tree, right? Now I got a tree, right? Again, for a long time there's no tree. uh, you know so it's like, but this time it came faster, for example, right? So you will have created a situation where trees are coming out at random times, right? And either one or two, right? It just so happens we got lots of twos together, but that's just a matter of time, right? So we'll get one sometime pretty soon, I'm sure. Okay, so see, now we got one tree, for example, right? So now what I'm trying to say is that by using, starting from what the retro bullet was doing, and adding a little bit of control on this, basically on the generation of these trees, I am able to create a situation where clones are generated in random numbers at random weights, right? So it makes the game somewhat interesting. Now, before I move away from the screen, I'm going to create three variables which will let me control the game as we go along, right? So I'll say, uh, variables, I'll make a variable called tree steps, right? This is the number of steps that the tree takes. I will use this to control the speed of the tree. When we go to the next level, we will make the trees come towards us faster, right? So I will say, when the flag is clicked, set, say, tree steps to maybe -5, let's say, and I'll make sure that this is set to tree steps called -5. So change x by tree steps. Tree steps must be a negative number, remember, because trees should come towards us from right to left. Yeah. Now, similarly, I want to be able to control how much do I have to wait for the next tree to appear, right? So here I've set from 3 to 5. I'm going to create two variables, right? So make a variable, let's say here, and I'll say tree min gap, right? uh, Tree min gap, and I also create a variable called tree max gap, right? Tree max gap. And as you will see later on, we will change these values midway through the code, and hence it's useful to put them as variables, right? So when this happens, I will set these two also. When flag clicked, I'll set tree, notice, be careful on which one you're setting. So tree min gap, it's 3, and tree max gap, which must be more than the tree min gap. Let's say I set it to say 5, right? So every 3 to 5 seconds, I want a tree to appear, and hence I will change. I don't need to show these. I will set tree min gap here to tree max gap, right? So now this code will continue to work exactly what it was doing, except that now it's flexible, right? So I got one tree this time, right? Again, I got one tree, right? Now it's getting a lot of ones because it's a random number. I might suddenly get two, right? So this so happens that it's getting lots of ones this time. That's okay. There will be two as well, right? And the waiting time is also changing between. See, now we got two, for example, right? So now it's working exactly the same. And with these, we will be able to control the rate at which the trees come towards us. And with the tree steps, I'll be able to control how fast the trees move towards us, right? So let's move further and give the cat and the tree a little bit of code to figure out if the cat is touching the tree, right? So remember, what I want to happen is that I will I will basically give some lives to the cat. If the cat is touching the tree, I will deduct one life, right? So what I'll do is I'll create a variable called, say, cat lives, right? Uh, Now I will set cat lives, depends up to you, but in my case, I'll set it to, let's say, 3, right? So I'll set it to 3. And in the tree, right, I'm writing this code in the clone. It's generally easier, right? I could do it other way as well, from the cat touching tree, but it's a little bit easier to write it in the clone, right? So I'll recommend that you write it in the clone, right? I just create one more loop here when I start as a clone, right? When I start as a clone, uh, if, let's say, if touching tree, so this you have done before, exactly same as a retro robot. So I'll say if touching, let's say I'll use this touching block, and I say if touching the, okay, it's called sprite one. So first thing I should do is to go and rename this sprite one to cat, right? I should have done this earlier, but nevertheless we'll do it now, right? So when I go here now, it says if touching cat, okay, if touching cat, then what do I want to happen? I want to say, let's say, reduce cat lives by 1, right? So I'll go to variables and I'll say change cat lives by -1. Why -1? Because I want the lives to reduce by 1, right? So cat lives will be 3 to start with. When I happen to touch the cat, right, the tree touches the cat lives becomes, say, 2, right? And as I always do with sensing blocks, put a small weight, because you do not want the lives to sort of diminish too fast. So let's say I put 0.2 seconds. You might have to fine tune this as well, right? In your game, the height, number of trees, the height of the tree, and this all has to be fine tuned together, right? Sometimes a little bit painful, but worth doing. Also, just to keep the game a little interesting, I will start a sound called pop, right? So that whenever I'm touching this cat, I'll start a sound called pop. Uh, Now, in this case, I'm not deleting the clone just yet, because I do not want the tree to end at the cat, right? I want the tree to go all the way to the end, and then anyway, it deletes itself by this code, right? So let's see if this works. And of course, I'm making my cat lives. If I add this forever block, then what happens is that my code starts doing this forever and ever again, right? So let's say I mean, if I jump over, it's fine. But if I don't, right, let's see, I'll make it touch this time. I touched and my cat lives became one less, right? So let's say I touched again. Again, I lost one life. That small pop sound told us that we have touched, and we, as a result, lost the life there, right? So with this, I shall pause here for a moment. I shall break this video. We will continue this video in the next part, where we will add all the other elements to this game. However, notice that the important bit of the game is already in place, right? The game is actually working. You can really play this right now, right? So of course we have to give the code what happens beyond this, and that's the next part, right? So let's just recap. We started with the blue sky backdrop. Blue sky backdrop, uh, we added this road kind of thing. Then we added code for the cat to give an impression of walking. We added code for the cat to make it jump, right? We added some variables to control these jumps and so on and so forth. We went on to the most important element, which is the tree. We started cloning it, right? Just like we were doing for the bullets earlier. However, we added some elements of randomness to create random amounts of weight and random number of clones, right? So that is this. You may want to create more clones, but remember the heights have to be adjusted, right? And then finally, we have given for now the code for our tree to be touching the cat and detecting that, so that we can keep track of how many lives does the cat has, right? Does the cat have? Okay. So with this, thank you very much for watching, and do tune into the next part of this video, which will complete this game. Okay. Thank you very much. Bye bye.